down draw a polygon here. And actually, you know, since we're not passing that point A anymore for draw a tiny rectangle, because we're using the x sub 0, y sub 0, we can actually, I think it'd be a little clearer to just move this line up a little bit, and then we can, you know, start our loop for all the vertices down here. So what do we do here? So we're getting the first vertex, right? So 0 is the index that's used a lot of times in programming to represent the first of a list, or we've seen it before, you know, as the first pixel, or the upper left hand pixel is 0, 0 in device coordinates, right? So the 0th point in the list of, or vertex in the list of vertices we get with this index of 0 here. So we set A to the first vertex, and then we go into this loop, and sometimes, you know, programmers are unnecessarily clever, and they write code that's obscure when it's not really that important to make it obscure. We could make it clearer with maybe a little bit of difference. Sometimes there will be a difference in efficiency, but what's going on here is not really, it's not really necessary to make it this obscure, I don't think. So what's he saying? Well, we're starting, first of all, we get our first vertex, so A. So A is now holding the first vertex. Then we start with this index I equal to 1. Okay, so we've already gotten the 0th vertex, right? So now we want to start looking at vertex number 1. Let's skip over this bit for a second, and let's just see what this says. So this says we've got our point A, right, which is the 0th vertex, and now we've set I equal to 1 the first time through our loop, and we're saying we're going to set B equal to vertices get 1 mod n. Well, 1 mod n, as long as, you know, n is bigger than, you know, 1 or whatever, then this is going to be just 1, right? So we're just going to get the first one. So if we have 3 vertices, let's say, then n is 3. 1 mod 3 is 1. So we're just going to, so we'll have the 0th and the first vertex, right? So the 0th vertex is going to be stored in A, and the first vertex is going to be stored in B. And we're going to draw a line from A to B, basically, because we have A dot x, from A dot x, A dot y to B dot x, B dot y. Okay. Then we set A equal to B. Okay, and then we loop again, and we get the next. We load the next vertex into B. Okay, so if you think about it, we need to keep doing this assignment here so that, you know, A becomes B, so that we can keep drawing from the last point we were at. So A becomes the last point we were at, and B is the next point. Okay, so that's the idea there. All right. So then, but then there's this funky stuff here with I equals n and not ready, break. So break means, you know, exit the loop. Okay. So what we got going here is we're checking to see if ready is kind of our indicator that, remember we had this obscure kind of test over here. We'll talk about some more later, but we had this obscure kind of test. This is a test, and I'll explain this some more later. This is a test to see if we're inside the little tiny rectangle. And if we are, then we set ready equal to true. Okay, so ready is only going to be true if we've completed the polygon, if we've clicked back in that initial square, or if we're on the first square, whatever. But let's say, you know, we haven't. Let's say we have some vertices in here that we're looping through, but we haven't clicked on the last one. Well, if we get to the end of our list, so n is giving us the length of our list. So if we get through all the elements in the list, but we're not ready, we haven't clicked in that little tiny rectangle, then we break out of the loop. Okay, but if we are ready, if we have clicked in that tiny little guy, then we're going to go here and we're going to get, now look at, if I equals n, right? If I equals n, so assuming I equals n and we're ready, okay? So if I equals n and we're ready, we'll fall through here, right? So in that case, we'll have n mod n, which is 0, and we'll get the 0th. So b now will be actually the first vertex. So we're going back to the first vertex and drawing a line from wherever we were last back to the first vertex. So we're completing the polygon. All right. So and you can kind of see also up here, if you look at the tests, that if we are inside that little square, we don't add another vertex here. See, we just say ready equals true. We only add a vertex if we're not inside the little square. Okay, so if we clicked inside the little square, we set ready equals to true, we're not going to go to where we clicked, we're going to go to exactly the point of the original click. So in other words, if we got inside that tiny little square, if we got close enough to our original click, then we're just going to close the polygon and say we've completed that polygon. All right. But again, like I said, this is kind of a long way around. What we could do is more something like, let's see, let's do we could declare our point B up here. Oops. And then instead of doing this, then we just go up to n and just say, we'll just loop up to n normally, but if we're ready, then at that point we'll set b to the first one. And then draw our line from A back to the first vertex. Right? So I just think this is clearer. Okay, so basically what we're saying is go through and draw all the points, and in fact this just needs to be get I. We don't have to worry about that modulo business. So that gets rid of another obscure piece of code. And we can, and actually, you know, we can get rid of this other parameter too. Let's do that. So let's say draw polygon. because you could just stick vertices size, and again, this adds some minor inefficiency to have to, if you have to repeatedly call size on this vertex, but it's not going to be noticeable. And you can always, when you're refactoring, the first thing you want to keep in mind is, how can I make this code really clear? And the worst thing that can happen is you make the code really clear, but it becomes inefficient to the point where, it slows things down visibly. Well, if it's really clear, then you pretty much have a good idea of where to go to make it efficient again, right? So, I don't know. To me, this makes a lot more sense. So I'm saying draw polygon. First draw the tiny rectangle. Get point A. And then, loop through for the size, where I is less than the size of the list. Go through all of them. Get the next one, basically, for B. Draw that line, set A to B. Keep looping through. And then, if ready, if we've clicked in the little tiny rectangle, then set B to the first vertex and draw that line there. So, I hope that's clear then now what this piece of code is doing. And yeah, again, if for any of this stuff, if you have any questions, send me an email.